The concept of an impact winter revolves around the theoretical period of extended severe weather brought about by the collision of a sizable asteroid or comet with the Earth's surface. Such a colossal impact, whether with land or a shallow water body, could release enormous amounts of dust, ash, and other materials into the atmosphere, effectively blocking sunlight. This, in turn, could drastically drop global temperatures. A cosmic object measuring about 5 km, 31 mi in diameter or larger, even if it struck a deep water body or disintegrated prior to impact, would still result in a monumental amount of debris in the atmosphere. It's conceivable that such an impact winter could potentially cause mass extinction, obliterating a vast number of existing species. An example of this could be the Cretaceous, Paleogene extinction event, which likely involved an impact winter, resulting in the extinction of most heavy tetrapods. While the Earth is bombarded by meteors regularly, most of these, even ones with a substantial 5m16 FTU diameter that cause an explosion equivalent to a kiloton of taunt, burn up before reaching the surface. Those that do reach us often descend in uninhabited areas, causing minimal damage compared to other natural disasters. The chance of a lethal asteroid or comet impact is statistically insignificant. However, a study in 1994 suggested a 1 in 10,000 chance of a large celestial body, around 2 km, 12 mi, in diameter, striking the Earth within the next century, which could potentially devastate the ecosystem and cause mass casualties. We also have asteroid 1950D, which currently has a 0.5 chance of colliding with Earth in the year 2080, substantially less than its initial predicted probability of 0.3 at the time of discovery. The more we learn about its orbit, the lesser this probability. In our solar system, over 300 short-period comets routinely pass near gas giants like Saturn and Jupiter. Their gravitational pull could affect the comet's trajectories, presenting a potential risk of Earth. Crossing orbits. While this is applicable to long-period comets as well, the chance with short-period comets is substantially higher. However, the likelihood of these comets directly hitting Earth is far less than a near-Earth object. No impact. The theory proposed by Victor Klube and Bill Napier suggests that even if a short-period comet in an Earth-crossing orbit doesn't directly impact, it could still present a hazard. It may break apart, creating a dust veil leading to a situation akin to a nuclear winter, causing long-lasting global cooling for thousands of years, a scenario that equates to the likelihood of a 1 km impact. The narrative primarily revolves around the catastrophic threats posed by potential impacts of large celestial bodies like asteroids and comets. The wrath of such occurrences finds its prior example in the annihilation of non-avian dinosaurs approximately 66 million years ago due to the Cape Boundary impact, an asteroid measuring roughly 10 km mc, 2 min, in diameter, possessing force surpassing 6 billion times that of the Hiroshima atomic bomb. This unleashed an explosion that left behind a 180 km, 110 mi, Chicxulub crater. The meteor's sheer mass ensures that either of these bodies, an asteroid or a comet, would primarily remain undamaged while crossing the Earth's atmosphere, producing dust and debris even if it landed in the ocean. However, an object smaller than 3 km would require a strong iron composition to successfully breach the lower atmosphere. Asteroids or comets can be metallic, stony, or icy, with the metallic ones standing a higher chance of reaching the Earth's surface without disintegration. On the contrary, the stony and low-density porous comet, like objects, typically burn, disintegrate, or explode before landing on the surface. These celestial impacts have a force magnitudes more potent than a volcano, triggering a series of events comparable to a mega volcanic eruption-induced volcanic winter called an impact winter. This event, marked by significant amounts of debris blocking the sun's radiation, can cause a significant dip in global temperatures, producing mass ejections of regolith and multiple firestorms. An investigation by Kurt Covey and his team revealed that a 10 km asteroid exhibiting an explosive force of around 108 mA might eject an enormous volume of microscopic aerosol particles into Earth's atmosphere. These particles could scatter throughout the atmosphere, absorb or refract sunlight prior to reaching the surface, cooling the planet in a manner akin to the sulfurous aerosol from a megavolcano, thereby causing intense global dimming, a hypothesis that has emerged controversially post the Toba eruption. A cataclysmic impact event of substantial power could potentially trigger volcanic activity on the opposite end of the Earth. Such activity could subsequently instigate a volcanic winter, a climatic phenomenon that could independently occur irrespective of other impact-linked effects. If the impactor of this event is a significantly large object, like the Key Doundry impactor thought to be around 10 km large and assumed to have contributed to the extinction of dinosaurs, it could ignite widespread firestorms with potential global reach, particularly in denser forests prone to these conflagrations. The release of water vapor, ash, soot, tear, and carbon dioxide into the atmosphere from these wood fires could alter the climate drastically, potentially causing the dust cloud blocking the sun to endure longer or dissipate quicker due to the increased presence of water vapor for condensation. Nuclei, if the dust cloud does persist, it could extend Earth's cooling time and possibly result in the formation of thicker ice sheets. In 2016, a research project drilled into the renowned Chicxulub impact crater to extract rock core samples from the impact site. The findings upheld existing theories surrounding the impact and its effect. They substantiated that the peak ring, composed of granite, an unusual geological element in seafloor deposits, was subjected to immense pressures, forces, and heat, experiencing transformation from its original state in an incredibly short span of time. The virtual absence of gypsum, indicative of vaporization into the atmosphere, as well as the subsequent occurrence of a massive megatsunami, provided further support to the belief that the impactor was large enough to create a 120-mile peak ring, expel molten granite from the Earth's depths, cause enormous water movements, and send a large volume of vaporized rock and sulfates into the atmosphere for an extended period. This scattering of dust and sulfates could have cataclysmically affected the global climate by causing drastic temperature falls and wreaking havoc on the food chain. In a world abundant with dust and debris, sunlight radiation is scattered back into space, resulting in dramatic changes on Earth. The aftermath of this cataclysm involves the destruction of photosynthetic life forms. Leaving the survivors in a dormant state until the revival of the sun, there might be hope for terrestrial inhabitants, as some microclimates, such as those in the Sprasov-Aragonite caves, could potentially house life underground. Ideally, greenhouses underground powered by fossil or nuclear energy could keep artificial sunlight devices running until the atmosphere gradually clears. However, the lack of sunlight and ensuing extreme cold poses significant threats to those above ground, possibly resulting in their deaths or diminished activity. The death of plant life could consequently trigger a widespread famine if there were sufficient survivors of the initial disaster. This would cause a spike in food prices in developing countries following initial crop failure. Developed nations have a slight edge due to their robust canned food and grain reserves, but these viable resources would quickly deplete if the impact winter extends beyond a year. If the catastrophic event mirrors the magnitude of the Key Doundry impactor, neither the northern nor the southern hemispheres would be spared, leading to global food shortages. Countries would need to stockpile substantial amounts of food for a year to prevent famines. The world average cereal stocks only cover about 30% of the yearly production. The aftermath of a comet or asteroid impact could financially drain nations tremendously, costing billions or even trillions of dollars for cleanup based on the targeted location. A direct impact on New York City, for instance, could drain billions in losses, heavily impacting its finance sector like the stock market, which could take years to recover. However, this horrifying scenario is extremely unlikely. As of February 20, 2018, there are 17,841 recorded near-Earth objects, and among them, 8,059 hazardous objects larger than 140 meters that may come within 20 lunar distances of Earth. Approximately 888 of these near-Earth asteroids surpass 1 km in size, making up 965 believed to exist.